Okay, here's our objective. And to me, what this means is, let's say you test a solution's pH, or whether it's acidic or basic, and you get some results based upon that. All right, here are your options. What does that mean about the solution's molecular view in your mind? What's there in terms of ions, and what solution could it be really? So that's what it is. What the objective is. Get a Now, just some fun facts. pH means pouvoir hydrogené, which is from the French meaning hydrogen power. And it literally means that the negative, or you can infer that pH talks about the concentrations of certain ions. Uh, H3O plus, hydronium, and hydroxide. pH literally means it's the negative log concentration of the hydronium ion. These brackets mean concentrations. We're not going to get into the math of this, but that's literally like the technical definition. Now, uh, when you're dealing with pH, if you've got a pH less than 7 or a low pH, you're talking about an acid. These are things like vinegar, hydrochloric acid, also known as acidic stuff. And if you've got a 7, that means neutral, and that's things like water, distilled water, but lots of things dissolved in water, like salt water. Salt water doesn't have a pH. Bases uh, have a pH greater than 7, and these are things like sodium hydroxide, hand soap, and they're often called alkaline solutions because of they're made of hydroxide with group 1 or 2 elements, 1 being alkali, 2 being alkali earth. All right. Now, I want to give you some molecular views of these things. This is like a low pH. This is like a 3. This is a 7. This is like a 10, and this is a 14, a high pH. Now you can see in all of these images, there's red and blue circles with a white background. The white background's supposed to represent the water, and the blue circles represent hydronium, and the red hydroxide. And you can see they're in all of them, regardless of pH. All right, and I want to talk about the comparisons to each other. In the acids, you have more hydronium than hydroxide. Water, you've got equal amounts. And in bases, you've got more hydroxide than hydronium. All right, and the disparity between the two ions as you move further from 7 gets greater, as the pictures show. Now, the trends of an ion is like as one variable goes up, what happens to these ion trends? If you notice in the acids, as the pH gets lower, the hydronium goes up and the hydronium goes up and the hydroxide goes down, whereas in bases it's the opposite. The H3O plus goes up and the OH negative goes up, and I think that I said that wrong. The hydronium goes down and the hydroxide goes up, and the basicity goes up. This is just a review in terms of terms, all right? Now, besides a molecular view, what types of acids would you have? If you had a low pH, what does that mean? It really could mean one of two things. It means you've got a strong acid or a weak acid, and which one it were would depend upon the concentration. You need to do some more testing. A really, really low pH, it's going to be a strong acid, and a really, really strong high pH, it's going to be a strong base. But there's a line between like 2 to 3 where it could be either, because depending upon the concentration of these solutions, as they get from dilute to concentrated, you could have one or the other. For example, a weak acid at a strong concentration, this is something like vinegar, could have an equal pH to a strong acid like hydrochloric acid with a dilute concentration. One thing, if it's got a 7, it's got a pH of 7. It doesn't mean there's no solute. It doesn't mean the solution doesn't have a concentration. It just means it's not an acidic or basic solute.